All right, today we're doing something a little different. We're going on a kind of digital archaeological dig. We've stumbled upon an entire career, just scattered across a bunch of old files and documents, and we're going to piece it all together to figure out what a real modern career blueprint actually looks like.
I mean, really think about it. What does a career path look like these days? Is it still that straight line we were all told about? You get a degree, you get a job, you climb the ladder? Or is it something a lot messier, way more complex, and honestly, a whole lot more interesting? Let's find out.
So this is what we're digging through. It's this wild collection of digital files. We've got everything from hardcore electrical engineering schematics to old-school COBOL code and even rejected research papers. At first, it just looks like a random pile of stuff. But the crazy part? All of this, it was all created by just one person.
Okay, so how on earth do you make sense of all this chaos? Well, you need a system, right? We're going to act like detectives here, organizing these scattered files to find the hidden patterns, to build a blueprint of this person's expertise.
And it turns out, when you start sorting, everything kind of falls into three main buckets, three pillars. First, you've got the foundation. That's all the deep theoretical knowledge. Then there's application, which is where all that theory gets put into practice. And finally, you have architecture. We're talking designing entire systems from scratch.
Let's start at the beginning, with the foundation. This is the absolute bedrock of their expertise. This is the tough stuff, the material you'd grind through in some really demanding university courses. It's the deep, abstract, and often pretty difficult theory.
And just look at the range of that foundation. This isn't just one narrow specialty. You've got advanced math sitting right next to complex control systems theory, the stuff that makes automation possible. And then boom, power grid analysis that literally keeps our lights on. You see how it's all interconnected? This is the hardcore theory that everything else gets built on.
And if you want to get a sense of just how deep this goes, the archive has work on things called semi-algebraic maps. Now look, you don't need to be a math whiz here. Just know that this is the kind of super high-level theory that lets engineers build incredible algorithms for optimization, basically finding the absolute best solution to a really, really complex problem. This is what separates a true expert from a hobbyist.
And here's where the rubber meets the road. This formula, it's used to calculate a specific type of electrical fault in a power system. This is not just some abstract problem in a textbook. Getting this calculation right is absolutely critical for designing safe electrical grids and preventing total meltdowns. So that deep foundation isn't just academic, it's tied directly to keeping people safe.
Okay, so that's the theory. Now for the fun part. How do you take all that brainy, abstract stuff and turn it into something real, something tangible? Well, that brings us to our second pillar, application. This is where knowledge becomes action.
And you can see that action right here. We've got detailed specs for two different PC builds. One is a high-end beast meant for performance, the other, a budget build with a strict price target. This shows a really crucial skill. It's not just about knowing how to build something. It's about applying those deep principles to solve a problem within real-world constraints, like money.
But it's not just about one-off projects. This person had a process. The archive shows a super structured approach, following what's called a system development lifecycle. That means careful planning, tons of testing, and sticking to global quality standards like ISO. That's the real difference between a hobbyist who makes something that works once and a professional who engineers a solution that's reliable, safe, and built to last.
Now for our third and final pillar, architecture. This is the highest level. This is where you zoom out. It's about moving past building the individual Lego bricks and instead designing the entire blueprint for the whole castle. And check this out. It's a record layout for a payroll program written in COBOL. Now, I know what you're thinking. COBOL seems ancient, but the principle here is absolutely timeless. This is a perfect, stripped-down example of data architecture. It's about designing the skeleton of an information system, defining exactly how every single piece of data is structured and stored.
And then you see this, the full blueprint for a modern crime management system for a police station. Just look at the level of thinking here. Use case diagrams, class diagrams, a whole client-server architecture. This person isn't just writing lines of code. They are architecting a complex, vital system to manage public safety data. That's a huge responsibility.
So we've got the foundation, we've got the application, and we have the architecture. We've seen the blueprint, but who's the architect? Who is the person behind all this incredible work? Let's follow these digital breadcrumbs and uncover the human story here.
This quote pulled from an abstract in the archive is a massive clue.
This person isn't just doing engineering, they're thinking about how we build careers in engineering. They're focused on things like open access and making education more transparent for everyone. And this chart, this tells the story perfectly. You see the wins, right? Patents, publications, awards. But look closer. You also see the struggle. 3 rejected articles. This isn't some superhero story of overnight success. It's a very human story about grit and persistence. Here's one of those big wins, a patent application to create a whole new framework for career discovery in his field. This shows a massive ambition, not just to play the game, but to actually change the rules for the better.
And then you see this, just one word, rejected, stamped on a research paper. The contrast is so powerful, it just makes this whole story feel so much more real. Building a career, a real one, is full of setbacks, and this digital record isn't afraid to show them.
And here he is, the person behind it all. This entire incredible digital history belongs to Chingombe Chitati Fiston, an engineer from the Democratic Republic of Congo whose work with the South African Qualifications Authority shows this deep, deep passion for both the practice of engineering and for fixing how we learn it.
So after deconstructing this one pretty remarkable career, what does it mean for you? Let's zoom out from this case study for a second and think about how you can start building your own digital blueprint.
Because when you really boil it down, a career is just a collection of artifacts, isn't it? It's the projects you've finished, the skills you've picked up, and yeah, even the stuff that crashed and burned. So take a second and really ask yourself, what's in your portfolio? What are the files, the projects, the experiences that tell your story?
Because at the end of the day, here's the big takeaway. A career today isn't some straight ladder you have to climb. It's more like a library, a unique personal library of knowledge and experience that you and only you get to build.